Hello everyone, this is Haiding Tian. In this video, we'll start to learn Chapter 3, 3.1 radian measure. In previous class, we have learned the degree measure. For the full rotation, we're starting from the initial side here and rotate counterclockwise. Okay, when I got here, this is 90 degrees. Got here, 180 degree. And here is 270 degrees. Continue to rotate all the way back is 360 degrees. This is a full rotation. Now, in the radian measure, one full rotation is 2 pi. Okay. If I have the initial side here and doing the counterclockwise rotation, when I got here, this is 1/4 of the full rotation. 1/4 times the full rotation is 2 pi, where we get pi over 2. How about continue to rotate 1/2 of the full rotation? That is pi, the half of 2 pi. And continue to rotate. This is 3 over 4, 3/4 of 2 pi. So here is 3 pi over 2. Continue to rotate. That's the full rotation, which is 2 pi. So, in the radian mode, the radian measure has no unit. So in previous lessons, we have learned the degree mode. So the degree measure, we have the unit is degree. You see 180 degree, 90 degree. The degree is a unit, but in the radian, we have no unit. For example, I say my angle is 2 equals 2. This is the radian measure because the radian measure, the 2 has no degree. All right, let's see next part. Let's see the relationship between the radian measure and degree measure. One full rotation or one revolution is 2 pi. That equals 360. And the half of the rotation is pi over 180. Next one, this is 1/4 of the full rotation. Pi over 2 equals 90 degrees. How about 3/4 of the revolution? That's 3/4 times 2 pi, 3 pi over 2, and also equals 3/4 times 360 degrees. That's 270 degrees. Okay, let's see. 180 degree, that's a half rotation or half revolution. That is the pi. Pi is in the radian mode. All right, let's see how to converting between degree and the radian measure. From the degree to radian, I need to multiply by pi over 180 degrees. From radian to degree, I multiply by 180 over pi. Okay, it takes a while to memorize them. Okay, let's see the example 1. Negative 135 degrees. I need to convert it to the radian mode or radian measure. So I need to use 135 degrees multiply by, I don't have a good multiplication sign. So multiply by pi over 180. So sometimes you're confused which one I need to choose. They are so similar. They all have the pi, they all have the 180 degrees. Okay, let's see. If I want to convert to the degree mode to the radian, that means there is a degree here, but in the radian part, there's no degree. I need to cancel out my degree or the degree symbol. If I multiply by pi over 180, the symbol canceled. You see this degree, they are canceled. Then I can get a radian measure or the angle in the radian mode. All right, let's see how to simplify this. 135 is on the top of the 1. So this is the top number and the 180 is the bottom. I can do the cancellation top and bottom. Are they all divisible by 45? Yes, they are all divisible by 45 because 135 divided by 45, it is 3. 180 divided by 45, that is 4. So they are all divisible by 45. So divided by 45, I'm having a 3 divided by 45, I got a 4. I'm having negative 3 pi over 4. The question is using pi as needed. So I don't need to simplify this. I don't need to find the decimals. All right, let's see next example. Next example is still convert the angle in the degree mode to the radian mode. So I'm using this angle 380 degrees multiplied by pi over 180 degrees because I want to cancel out the degree symbol, and then in the radian mode, no degree. All right, what is the next? I can also cancel out the zeros. And 38, 18, they are all divisible by 2. So divide by 2, 9. Divide by 2 is 19. So I'm having 19 pi over 9. The question says round your answer to 4 decimal places. So let's use our calculator. So 19 pi. So where is the pi? Different calculator has a different pi. So if you have a TI-30XS, you will find that that pi is on the first column, and I think 1, 2, 3, 4, fourth row. So first column, fourth row. But in different calculator, so for example, this calculator on my screen, you will see it's so tiny, tiny, tiny here. You see the symbol here. You see my button here, this one, and above it, there is a small pi. Oh, that means I can click second and this caret sign. Oh, that is the pi. And different calculator, you just find where is your pi on your keyboard. I forgot what I should do the computation. So 19 pi over 9. Let's click 19 and then click second, click caret sign. This is 19 pi divided by 9. Hit enter. So this is the solution. This is the angle in the radian measure. Okay, let's put the solution here. That's about 6.632251158. No unit. Or so if you really want to add something, you can say this is in the radian mode or radian measure, or using radians. And the question says round to 4 decimal places. Okay, the fifth is 5. So I need to add 1 at the 2 part. So my solution is 6.62, sorry, 6323. All right, let's see next example. I want to convert the radians to degrees. What should I do? So I have pi over 12. From this one, I need to multiply it by something. Then my solution has a degree. It's a too big a degree. Okay, to have that degree, I need to have 180 on the top because 180 has a degree. Then divided by pi. Pi canceled, and then 180 divided by 12. 180 divided by 12, that's 15. So I'm having 15 degrees. Let's see next part. Convert the following radian measure to degree, round to the nearest minute. Okay, so from the degree to from radian to degree. I found why I'm making mistake because I look at this and say something else. All right, from radian to degree, 2.52. I need to multiply by something, then get a degree here. So what I should multiply? That must be 180 degrees over pi. Pi, so pi is a number equals 3.1415 something. So you can find it on your calculator without inputting 3.1415 something. All right, let's continue to use our calculator to find the solution. Okay, let's clear the screen. That's a 2.52 multiplied by 180 divided by pi. Pi is second caret sign, and then hit enter. So this is the degree mode. So I cannot say I'm having equal sign. I need to have approximately equals 144.3853668 degrees. I cannot stop here because the question is a little bit tricky. It has round to the nearest minute. Do I have minutes in my solution? No, I only have the degree. So how to find the minutes part? Okay. So this one, I can separate 144 degrees and 0.385 53668 degrees. I can convert the decimals to the minutes. How to do that? That's 144 degrees plus, use this decimals, multiply by 60, 0.3853668 multiplied by 60. Then what is the new unit now? This is the minute. So let's use this. So how to find the decimal digits? I can use my previous solution minus 144. Okay, that's the solution. Then use this one multiplied by 60. What do I have? It's 23.1218 something. But the question is round to the nearest minute. That means I don't need to have decimals. I only need the integer. That is 23. The digit after 3 is 1. It's too small. So I ignore them. So I have 23 minutes. So this one equals 144 degree plus 23 minutes. And then this one is 144 degrees 23 seconds. Sorry, minutes. All right, so more steps. Let's see next one. 4. Convert 4 to the degree mode. Let's use the 4 multiplied by 180 degrees over pi. And use our calculator to find the solution. That's 4 times 4 multiplied by why I clear this? 4 times 180 divided by pi, second caret, enter. So I'm having the degree is 229.1831181 some degrees. So I want to convert it to the degree and minutes mode. That means I need to separate my degree and the decimal part. So convert this one to be minutes. So use this. Use this. I can ignore one step. Use this, multiply by 60. Then I can I change the unit here. I make a minute here. Now let's use our calculator to find the minutes part. So use the previous solution minus 2 to 9 minus the integer part. I'm having decimals multiplied by 60. I'm having 10.987083. That means I only keep the integers. Can I say my minutes part is 10? No, because after the digital point, I have a 9. 9 is very big. So be greater than or equal to 5. I'm having 11 minutes. Now I'm having 11 minutes. Then combine them together, 2 to 9 degrees, 11 minutes. All right, it's pretty cool. Let's see next part, coterminal angle. In last, I think several videos ago, we have learned the coterminal angles in the degree measure. So coterminal angle is if I have angle beta or alpha, I plus or subtract or minus 1 full rotation or minus 1 full rotation or n times the full rotation. I'm having the same terminal side. They have the same initial side. They have the same terminal side. Also, they have the same trig functions values if they have the same terminal side and same initial side. All right. In the radian mode, so if I have an angle we call alpha, for example, my alpha is pi over 6. So my alpha plus or minus n times 1 revolution, which is 2 pi, I'm having the coterminal angle of alpha. All right, assume that my alpha is pi over 6. If I add 1 full rotation, you see, add 2 pi, I'm getting a 13 pi over 6. So that is the coterminal angle of the pi over 6. If I add 4 pi, that's 2 rotation, I got 25 over 6. That is also the coterminal of 6 or pi over 6. So subtract 1 full rotation, negative 11 pi over 6. That's the coterminal of the pi over 6. All right, here we will see a unit circle, and it will help you to convert the degree to the radians. So for example, if I have 30 degrees, I want to convert it to radians. I know I need to multiply by pi over 180. So this is pi over 6. And if I have 45 degrees, multiply pi over 180 degrees, I'm having pi over 4. And some other special angles like 60 pi over 180 is pi over 3. So you will see these are very important angles shown here. So please spend some time to memorize this. If you don't know how to memorize them, at least you need to know how to convert them. What I need to multiply. Oh, I made a mistake. Here must be multiplication sign. Okay. All right, let's continue. Find the coterminal angle on 0 to 2 pi. Okay, I have a negative angle. Theta equals negative 5 pi over 6. We have learned if I have negative angle, I can add 1 revolution to maybe several revolutions to make a positive angle, and make sure your coterminal angle is in 1 full rotation. So how about my theta negative 5 pi over 6 plus 1 full rotation, 2 pi. Okay, I'm adding a fraction and the integer. I need to convert to both of them to be the fraction, and the bottom they have the same denominator, so or same bottom. So 2 pi equals 2 pi over 1. I can multiply the top and bottom by 6. Enlarge top and bottom. Same time, I'm having negative 5 over 6 plus top is 12 pi over 6. They have the same bottom. Do the subtraction or addition on the top. Negative 5 pi plus 12 pi. That's 7 pi. Okay, I found the coterminal. That's 7 pi over 6. And also this angle is inside the range from 0 to 2 pi. How about the second one? Theta equals 13 pi over 2. That's a big number. That's a big angle. So what is 13 pi over 2? 13 pi over 2 is 6.5. So 6.5 pi. So if I subtract 1 full rotation, 2 pi, still is too big. It's not in this interval, 0 to 2 pi. So how about minus 4 pi? That's 2 rotations. No, it's still not in the interval. So how about 3 revolutions? That's 6 pi. Yes, yes. So let's subtract 6 pi. All right, use this angle, 13 pi over 2 minus 6 pi. 6 pi equals 6 pi over 1. So make the top and bottom, enlarge the top and bottom, make sure they have the same denominator. So 13 pi over 2 minus 12 pi over 1, over 2. I'm having pi over 2. So pi, the half pi is the coterminal of the 13 over 2 in the interval 0 to 2 pi. All right, let's see next part. Example 6, find the value of the trig function. Okay. If the question is, find the value without using calculator, how do you do that? What is sine pi over 3? I know that in the degree mode, the pi over 3 is 60 degrees. And what is sine 60 degree? I ask you to memorize these special angles trig values, right? The sine 60 is square root of 3 over 2. So right now, if you're not familiar about the radian mode, so convert this one to the degree mode and then find the trig values. All right, so sine pi over 3 equals square root of 3 over 2. And how about cosine pi over 4? Pi over 4 is 45 degrees. Cosine pi over 4, cosine 45 is square root of 2 over 2. How about tangent pi over 3? Pi over 3 is 60 degrees. Tangent 60 is square root of 3. All right, let's see next part. Sine negative pi over 3. Where is sine negative pi over 3? This is not like a very not a positive angle. That's a negative angle. I'm rotating clockwise from initial clockwise rotation I got here. So this angle is pi over 3. I rotate pi over 3 angles I got here. Okay, tell me, what is the coterminal angle of the negative pi over 3? Oh, coterminal angle means my initial side and the x-axis, the acute angle formed by the x-axis and this terminal side. Oh, this pi over 3. All right. In the fourth quadrant, we know this is Q1, Q2, Q3, and this is Q4. In fourth quadrant, sine is positive or negative? Negative, because ASTC, fourth quadrant, the cosine and its reciprocal secant is positive. In the fourth quadrant, sine is negative. Okay, so this one equals negative sine is of its reference angle, which is pi over 3. What is sine pi over 3? Is that sine 60? Yes, it is. Sine 60 equals square root of 3 over 2. So the solution is negative square root of 3 over 2. How about next one? Oh, second, negative 15 pi over 4. So when I saw this one, this angle, I don't like this angle. This is not what we have learned all the time. We can use the coterminal angle formula to convert it to a positive angle, which we are familiar with. All right, let's do this. So let's only focus on the negative angle. So this is negative 15 over 4 pi. If I add one full rotation or two rotation or 3 rotations, can I make a positive angle? How about 2 pi? I think it's too small. 2 pi equals 8 pi over 4. I'm still making a negative angle. How about 2 rotation or 2 revolutions, which is 4 pi? Okay, 4 pi equals what? Negative 15 over pi, pi over 4. 4 pi equals 8 pi over 2, and also equals 16 pi over 4. 16 pi over 4. So let's do the computation. They have the same bottom, and do the addition on the top. I'm having pi over 4. All right. Second pi over 4 is 1 over cosine pi over 4. What is cosine pi over 4? Square root of 2 over 2. And then I need to do the computation. Keep, change, flip. Keep the 1, and then make the division line, this one, to be a multiplication. And then flip the 2, square root of 2 over 2. Flip the bottom fraction. I'm having 2 over square root of 2. Then I'm having 2 over square root of 2. We need to rationalize this expression, square root of 2, top and bottom. I'm having 2 square root of 2 over 2. 2 to cancel. Oh, square root of 2. So solution is square root of 2. This one we use a lot of space. Let's see next one, cotangent. Cotangent 2 pi over 3. Where is 2 pi over 3? 2 pi over 3 is in the second quadrant, because from here to here is 1 pi. And then 2 pi over 3, we divide the pi into 3 parts. So this is 2 pi over 3, and this is pi over 3. Okay, too much information here. Okay, why I'm saying that? Sorry, I'm sorry. Okay, this is 2 pi over 3. So how to find the cotangent 2 pi over 3? So this is 1 over tangent 2 pi over 3. 2 pi over 3 is also means 120. You can directly give me the solution, which is negative square root of 3 over 3. But some of you say, I like the reference angle. So the reference angle formed by the terminal side and the x-axis is pi over 3. So in the second quadrant, tangent is negative or positive? ASTC, tangent says, oh, I'm negative in second quadrant, so I'm having negative sign. And then I'm having tangent of its coterminal pi over 3. And then 1 over negative. So what is tangent pi over 3? Tangent square root of, that's square root of 3. Then I move the negative sign in front, and I'm having 1 over square root of 3. Then we need to rationalize this expression. I'm having negative square root of 3 on the top, and then the bottom is 3. So the solution is negative square root 3 over 3. Okay, we have a lot of methods to solve this one. Okay, let's see next 2 examples. Number G, so cosine 5 pi. Where is the 5 pi? So every time I'm looking for the function's value, I need to find where is the angle. Let's find the angle. 1 full rotation is 2 pi. 2 full rotation, 4 pi. And then another rotation, 5 pi. Oh, is here. rotate several times, and then I got my terminal side. My terminal side is here. Even I have I don't need to rotate several times. I just need to find where is the terminal side. Okay, it's a point here. So what is the coordinate of the point here? The coordinate is -1, 0. We just assume an easy one. Make sure the r radians is 1. So we talked about this in the degree mode. If I have the angle on the y-axis here, 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 and here, we just choose some special numbers like 1, 0, and here is 0, 1, and -1, 0, and this point is 0, -1, and then find their trig functions value. And for this one, cosine 5 pi. So cosine 5 pi equals x over r. What is the x? -1. What is the r? 1, because the distance from the point to origin is 1. So the ratio is -1. All right, let's see next one. Is this point on the xy plane? Sorry, xy axis? Yes, it is. Let's see, where is it? It's here. 3 pi over 2 is the rotation from here to here. Can you tell me what is the coordinate of the point? I can say this one, 0, -1. All right, we have x value, y's value. Can you find cosecant? What is the reciprocal of cosecant? Oh, you can use this way. You can find the sine first. Or you say, I know that cosecant equals r over y. So r is 1 and y is -1. The ratio is 1. Or you say, I still want to find what is the sine 3 pi over 2. Find this one first, and then flip this. Find the reciprocal, and then you also find, oh, the solution it is -1 because you have negative sign here, -1. All right, we are done for the 3.1. This is an interesting class. If you have any question, please let me know. Have a good day. Bye.